In this video, we're going to look at the ambiguous case for solving triangles. Now, prior in section 6.1, you've looked at solving angle, angle, side, and angle, side, angle. But when you have two sides, side, side, angle, you have to look carefully to see how many solutions there may be for that particular triangle. And that's why it's called the ambiguous case. So this starts on page 406 in your text, and at the top of page 406 is this figure that describes the different cases for triangles. And it's accurate. It says that for an acute angle A, if you're given side A, side B, and an angle A, that you have four possibilities. These are the possibilities when A is acute, and these are the possibilities when A is obtuse. But this figure isn't quite as clear as I would like it to be, especially about the angle, because what happens is this figure talks about angle A and side B, but all that's important is you have an angle and the side adjacent and the side opposite. And if you'll think about it that way, you'll be able to plug the different problems in that we give you during this part of the topic. So let's take a look at it this way. Presenting the information this way, this figure talks about the situation where you're given an angle, the side adjacent to the angle, and we'll call that ADJ, and the side opposite the angle. And that way we're not confusing the terms which is A, which is B, and which is C. So we'll use a couple of the examples in the book to show how to use this picture to decide how many solutions you're looking for and what type of process you need to go through for doing those solutions. So first, let's look at example 3 that says we have A is equal to 22 inches, side B is equal to 12 inches, and angle A is equal to 42 degrees. If we sketch that, we have 42 degrees for the angle. The side opposite the angle is 22 inches, and the side adjacent then has to be 12. Now we can label this several ways. We could call this A, because that's what they call it in the problem. This is little a, the side opposite the angle. This is B, so that means this is angle B, and then this has to be angle C and side C. But for purposes of our problem, we want to call this the angle, and we want this to be opposite, and we want this to be adjacent. Now, since angle is acute, that says that using our chart, we now have angle is 42, adjacent is 12, and opposite is 22. Well, the angle is acute, so we need to calculate H equals adjacent sine angle. So that's easy. We can do H is equal to 12 sine of 42. So that works out to H equals 8.03. Now we can make some decisions. Is H greater than opposite? Well, 8 is not bigger than 22, so this isn't what we're looking for. Is h equal to opposite? No. If h is less than opposite, which it is, and opposite is greater than adjacent, so 22 is bigger than 12, that says we are looking for exactly one solution. So now we know that we can go ahead and use law of signs and find one solution, and when we're finished with that one solution, we know that we're done with the problem. And that's how example 3 works. You can go ahead and finish that example. Just to illustrate another type of this problem, let's try again with example number 4. So in this case, we have an angle is 85. The angle opposite, or the side opposite that angle, is 15. And the side adjacent to the angle is 25. Well, so 85 is acute, so that says we're working here. We need to do h is equal to adjacent sine of 85. So adjacent is 25. So adjacent sine of 85 works out to 24.9. And now we can start comparing. Is h greater than opposite? Well, 24.9 is bigger than 15. So that says there are no solutions. And you can stop at that point. You really don't have to do anything else with that problem once you find out that h is bigger than opposite. So we're finished. To start example 5, we have the angle is 20.5. The opposite is 12. And the adjacent is 31. So angle is acute. That says we're working over here. Then h is adjacent sine of 20.5, which is equal to 10.9. So now, is h 10.9 greater than opposite? 10.9 is not greater than 12, so that's not it. It's not equal to opposite. H is less than opposite, and is opposite bigger than adjacent? No. So that says we have this situation where there are more than one solution. We have exactly 2 solutions, and this figure illustrates that you have one solution that is on this side of the right triangle and another one on the opposite side. These 2 opposite legs are the same length, but it forms 2 different triangles. Almost envision it as if this were a stick that you were rotating down until it touched. It could touch here, or you could rotate it around this way until it touched there, and you get 2 different triangles. So, example 5 shows the process that you use for working that, and I think if you just work through that, you'll see how it goes. So give it a try, and then if you need to go through it in class, just ask and we'll do that.